Okay, we're going to switch gears again. This time we're going to move over to the world of business. And there's a lot of applications that calculus has in business, especially talking about profit and revenue and costs. So let's talk a bit about terminology, just because I know some of you are not business people. Before we go into the actual mathematics. So if we have a business model in which X represents the number of products or services sold, I'm going to help break this down, and we're going to pretend like this is a lemonade stand. So, uh, P of X represents the demand or price, the amount that we're charging for the service. And sometimes it'll be fixed. Sometimes it could be 25 cents. Sometimes it might change depending on how many cups we sell. Maybe we sell lots of cups, so we can bring the price down, or maybe we're not selling very many, so the price goes a little higher. We can have the revenue function, the amount of money that we're taking in. So basically, if we sell 10 cups of lemonade at a quarter a piece, we're making $2.50 because we multiply. The revenue is going to be equal to the number of cups that we're selling times the price for each cup. We can also have a cost function that represents how much we have to spend for a business. And we can have the profits, which is just the amount of money we take in, and we subtract out the money that goes out. So the revenue minus the cost. So with that, we can also have derivatives for each of these. Let's talk about that really quick. We can have a derivative for our cost, which is c prime of x, or we could say dc by dx. And that's what we call the marginal cost. For our derivative for our revenue, it's r prime of x, or dr by dx. And that's called the marginal revenue. And we can have the derivative for our profit function, which is p prime of x, or dp by dx. And that's called the marginal profit. Now, that word marginal just means, let's say, when we sell 100 cups of lemonade, how quickly is each of these changing? How quickly is our cost changing? How quickly is our revenue changing? How quickly is our profit changing from when we go to our 100th cup to our 101st cup of lemonade? So the one last thing I want to mention to you really quickly for marginal profits, we know that's just the derivative of the profit function. We said that that's just the revenue minus the cost. So we can take the revenue minus the cost and take its derivative. And we know, using the subtraction rule for derivatives, that's just the derivative of the revenue function minus the derivative of the cost function. So I know this is a lot of information to throw at you. Hopefully this will all make a little more sense when we try an example. So let's get into it. So, by the way, I'm going to apologize in advance. The spacing on my PDFs has changed a little bit since I first made the course. So just write small and hopefully it'll all fit. A company sells 1,500 movie DVDs per month at $10 each. Market research has shown that sales will decrease by 125 DVDs per month for each 25-cent increase in price. So you may have seen these types of problems when you were in grade 9 or grade 10. We're going to come back to them a little bit. So it's asking us to find the price function. So let's use some let statements to help us out here, because I'm going to warn you with these types of problems. They're usually helpful, especially when we're talking about number of DVDs versus increases in price. You might remember that let statements are very helpful in these types of problems. So let's say let P represent the price, and when we're talking about P, we're talking about that in terms of increases in price. So let's come up with variables represent the number of increases in price. So let N represent the number of increases in price. We're talking about 25-cent increases in price, so let's specify that. So 25-cent increases in price. And we also have, we want to find, with demand, we want to find the price in terms of the number of units sold. So let's come up with a variable for that. So let X represent the number of units sold. So for that, let's use the information from this problem. So let's reread it again. A company sells 1,500 movie DVDs per month at $10 each. Market research has shown that sales will decrease by 125 DVDs per month for each 25% increase in price. So essentially, what you should take out of that is that we are starting at $10, and then we're going to have a certain number of 25% increases in price. So the way we can represent that is $10 to start plus 25 cents times however many increases in price that we have. So if we increase it once, it goes up by a quarter. If we increase it twice, it goes up by 50 cents, and so on and so forth. So now that we have that, let's use the other information that we have, and we can figure out an expression for how many items that we sell, because we have 1,500 DVDs, and every time we increase the price, we decrease by 125 DVDs per month. So if we want to find an expression for X, we're going to start at 1,500. And every time we increase the price, we're going to decrease by 125 units. So minus 125N. So now our goal is we want to find P in terms of X. So what we're going to do is we're going to use a little bit of substitution, and we're going to get rid of that N, and we're just going to leave it with P's and X's. So let's take our X expression and let's rewrite it so that way the N's by itself. So that's going to be X minus 1,500 is equal to negative 125N. Or we divide out the negative 125 and we get X minus 1,500 over negative 125 is equal to N. Or we can flip all the signs, and up top we get 1,500 minus X over 125 is equal to N. And now we just plug that into our P function. P is equal to 10 plus 0.25 times N, or in this case, let's plug in that expression that we just found for N. So 1,500 minus X all over 125. And then we just simplify using algebra, and if you do it correctly, it should work out to 13 minus X over 500. So now we have an expression for our price in terms of the number of DVDs that we're selling. So next part asks us to determine the marginal revenue when the sales are 1,000 DVDs per month. So to do that, marginal revenue means that we need to find the derivative of the revenue function. So we have to find a revenue function first. And think back to our lemonade stand problem. We said that we're going to take the number of cups of lemonade that we're selling and multiply it by the price. So in this case, that's going to be X times, and in the last one we found out that the price function is 13 minus X over 500. Because remember, the price isn't fixed. It changes based off of how many DVDs that we sell. So in this case, that's going to be 13X minus X squared over 500. So now that we have that, now we can find the marginal revenue, the derivative of that revenue function. So take the derivative of 13x minus x squared over 500. So term by term, that's going to be 13x becomes 13, and then x squared over 500 becomes 2x over 500. Think of that as a coefficient of 1 over 500, if that helps. or that becomes 13 minus x over 250. So lastly, what it's really asking for is the marginal revenue at 1,000 DVDs per month. So what that is that's R prime of 1,000, which is equal to 13 minus 1,000 over 250. 1,000 over 250 is just $4. So that's 9. So lastly, let's put a therefore statement. So therefore, at 1,000 DVDs sold, the marginal revenue is $9 per DVD. So essentially that means that the revenue is increasing at a rate of $9 per DVD. So at 1,000 DVDs, the 1,000th DVD, we're going to be bringing in $9 off of that one, which may not be the same for maybe the 100th DVD or the 10,000th DVD. It'll all change depending on how many we're selling. So question C, the cost of producing X DVDs is C of X is equal to negative 0.004 X squared plus 9.2X plus 5,000. Determine the marginal cost when production is 1,000 DVDs per month. So in this one, it's asking for the marginal cost at 1,000 DVDs per month. So we're looking for C prime of 1,000. So first step, let's find the derivative of our cost function. That's going to be, let's go term by term. So we move the 2 out, it becomes negative 0.008x. And then 9.2x just becomes 9.2. And then the plus 5,000 is a constant, so it goes away. So finally, we do C prime of 1,000. So we're going to do negative 0.008 times 1,000 plus 9.2. And if you do the math on that, it should work out to $1.20. So therefore, at 1,000 DVDs sold, the cost is increasing at a rate of $1.20 per DVD. So the last question it asks is, what is the actual cost of producing the 1,001st DVD? So the way we're going to do that is we're actually going to not use derivatives for this. We're just going to use a little know-how. And we know that if we take C of 1,001, that is the cost of producing 1,001 DVDs. So what we're going to do is we're going to subtract off C of 1,000. And that is going to get rid of the cost of the first 1,000. And it's just going to leave us with the cost of the 1,001st DVD. If you do that correctly, you should get something like 1.196, which we can round up to $1.20. So we're just going to plug in 1,001 into our cost function from part C, plug in 1,000, and we get about $1.20. So the actual cost to produce the 1,001st DVD is $1.20. Now, before we leave this, just one last thing I want to point out. You should notice between C and D that you actually got the exact same number, $1.20. Might have been rounded a little bit, but essentially they're the same number. And there's a reason for that. Now, remember we said that's the rate of change for a particular number of units sold. So basically, when we talk about marginal cost, marginal revenue, marginal profit for X number of units, let's say if we're going for 1,000, you have for 1,000 units. Basically, we're asking ourselves, what is the change in cost when we go from 1,000 units to 1,001 units? So basically, how much is each unit costing us for, or how many at that particular number of units? How much is it increasing our costs, our revenue, our profit? So that's essentially the principle behind revenue, cost, revenue, and profit. Is just talking about the change in each of those different factors in our business. So that's pretty much it for what we're going to deal with for business. Make sure you try some of those practice problems, and I'll see you in Unit 5.